Hey everyone, and welcome back to The Explainer. Today we're unpacking a really fascinating and honestly kind of alarming shift happening right now in the software industry. We're going to look at how a totally harmless, even brilliant AI prototyping philosophy somehow mutated into a massive professional software crisis. We're talking about Andrej Karpathy, this whole concept of vibe coding, and the inevitable rise of what people are now calling Codeslop. To really grasp the scale of this, I want you to just picture this scenario for a second. Imagine you're lying on an operating table. Your surgeon casually strolls in, washes their hands, and announces they're just going to vibe operate today. Yeah, they're not going to overthink your specific anatomy. An AI assistant suggested an incision path, it looks pretty reasonable, and they just got a really good feeling about the general approach. What do? You get off that table and run out of the hospital immediately, right? Or what if your financial advisor called and said they were vibe investing your entire retirement fund based on some good energy and a few AI suggestions? You'd literally fire them on the spot. Okay, let's dive into this, because this comparison hits the nail on the head. We would absolutely never accept vibe surgery or vibe investing. So why on earth do we accept vibe coding as a completely legitimate way to build the software that runs our businesses, our financial systems, and our medical records? Well, as our source material points out, it all comes down to deferred consequences. See, a botched surgery has an immediate, undeniable outcome. But bad code? Bad code produces this creeping, compound failure that's really easy to ignore at first. The consequences are deferred. And vibe coding just hit the fast-forward button on how quickly all those consequences pile up. So, how did we get here? Let's take a look at Section 1, the vibe coding phenomenon, going back to early 2025. Now, you might recognize the name Andrej Karpathy. He's undeniably one of the most important figures in modern AI, known for his incredible work at OpenAI and Tesla. And he actually coined the term vibe coding to describe this process of leaning fully into AI assistance. You basically stop worrying about the underlying code, you just accept whatever the model spits out, and you ship it. Now, for Karpathy, this was a perfectly reasonable, honestly awesome workflow for weekend prototyping. If you're a brilliant researcher just messing around with a new idea on a Sunday afternoon, you don't need production-grade safety. You move fast, you learn, and you throw it away. No big deal.
But here's where things went completely sideways. It's a classic case of the platform effect. Karpathy has immense, totally well-deserved credibility. When he speaks, the industry takes notes. So the result wasn't exactly what he intended. An entire generation of developers, many of whom had literally never shipped production software at scale, took this weekend prototyping hack and adopted it as a professional gold standard. They saw it as permission. And because it arrived right as AI tools made it incredibly easy to generate code that looked production-ready, this philosophy just spread like wildfire into startup pitch decks and engineering teams everywhere.
Which brings us to the very real fallout of that misunderstanding. Let's jump into Section 2, Welcome to the Codeslop Era. Because of vibe coding, we're now dealing with this huge phenomenon called Codeslop. This is exactly what happens when you optimize entirely for shipping speed and just throw quality out the window. Suddenly, organizations are flooded with this massive volume of AI-generated software that gets shipped in record time, but completely lacks maintainability or any real-world value. You end up with, 200,000 lines of AI code that absolutely nobody on the team, not even the original author, actually understands.
And this brilliantly illustrates the sheer scale of the problem. Check this out. Data from the Financial Times shows that since this whole agentic AI era began, iOS app releases have surged by a massive 80%. But here's the crazy part. Apps with actual significant usage, they've remained totally flat. This gap right here is the undeniable signature of Codeslop. It's this massive, overwhelming increase in the volume of software being shipped, with absolutely zero increase in the value of software that people are actually using.
And let me tell you, the enterprise world is hitting a serious brick wall because of this. Look at these Gartner projections for 2027. They're projecting that 30% of generative AI proof of concepts are just going to be abandoned, and over 40% of agentic AI projects will be flat out canceled. And why? It's not because the AI couldn't write the code. It's because that AI-generated code works flawlessly in a flashy 10-minute demo, but fails miserably when you put it into real-world production. It can't be maintained, it can't be extended, and it certainly can't be trusted. The vibe was great for sure, but the codebase turned into a massive liability. So, what's actually breaking down under the hood? Let's dive into Section 3, Sacrificing Software Quality. At its core, vibe coding systematically ignores anything that doesn't show up in a demo. It essentially breaks down across these four pillars. First, you got functional quality. The AI handles the obvious, happy path perfectly, but completely whiffs on the weird edge cases and complex error handling. Second, non-functional quality. Things like security, memory management, how the app performs under heavy load, that requires intentional architectural design, not just pattern matching. Third is maintainability, meaning code that human beings can actually read and update. And fourth, operational quality. Vibecoding gives you zero observability, no rollback safety, and no documentation for when things go wrong. But honestly, it's that third pillar that does the most damage.
Now, what's really interesting about this is how maintainability acts as the silent killer of the Codeslop era. When you generate code super fast without caring at all about readability or modularity, you create this giant tangled puzzle. It functions, sure, but it can't be understood. And when that system eventually breaks, and trust me, it will break, diagnosing it is an absolute nightmare. Fixing unreadable AI code ends up costing multiples of what it would have cost to just build it right the first time. The developer who prompted it can't even explain it to you because they never really understood it themselves. They just accepted the model's output.
But beyond the code itself, there is a much deeper human cost to all of this. Let's move to Section 4, the generational skill gap. Let's move to and see how this builds an incredibly dangerous dynamic for the new wave of developers. Historically, foundational learning meant reading other people's messy code, hunting down obscure bugs, and inheriting legacy systems. It was tough, but it built serious engineering muscle memory. Today, though, because of intense economic pressures and the rise of AI tools, entry-level hiring has dropped off. The junior devs who do get hired are thrust right into these prompt-driven workflows. They spend all day writing prompts and accepting outputs, completely skipping the hard, unsexy work that actually forces you to understand software on a deep level.
And this creates a massive vulnerability for the whole industry. Generating code that merely looks like it works is an entirely different skill set than having the actual judgment to evaluate if that code is secure, correct, and maintainable. If you spend 3 straight years just vibe coding, you haven't built engineering judgment. You've just learned how to make things appear functional in a meeting. And that knowledge gap, it only becomes visible when production goes down and everything's on fire.
Okay, take a breath. It's not all doom and gloom here. Over the next 2 to 3 years, as the maintenance debt on these systems becomes literally impossible to ignore, we are going to see a huge optimistic shift. Welcome to Section 5, the right coding correction. This correction is being dubbed right coding. And let's be super clear, right coding is not a rejection of AI. AI tools are absolutely amazing and the productivity gains are very real. But right coding is AI-assisted development that demands rigorous, old-school software engineering discipline. It uses AI to accelerate and amplify your engineering judgment, not to replace it completely. It maintains strict accountability for functional correctness, security, and making sure the code is actually readable down the line. So what does this actually look like in practice? Well, step 1, you generate the AI code, but you treat it strictly as a first draft. Step 2, you get in there and critically evaluate that code line by line. Step 3, you guarantee the full system quality, making sure you cover all those edge cases and security flaws we talked about earlier. And finally, step 4, you retain professional accountability. Think back to our surgeon. Just like a surgeon using a robotic assistant is still 100% responsible for the outcome of your surgery, the human engineer remains strictly responsible for the final software deployment. No excuses.
So, the crucial point is summarized perfectly right here in this quote from our source material. Vibe coding said, "The vibe is enough." Right coding says the vibe is where you start. I just love that. It is all about bringing real professionalism back to the craft. The tools have changed, for sure, but the accountability of the engineer, that cannot change.
I want to leave you with this final thought to reflect on as you go about using AI in your own day-to-day work. Are you actively building foundational engineering skills, or are you just generating code slop? It's really time we start taking software seriously again. If this explainer helped you make sense of this massive shift happening in tech right now, please hit that like button and be sure to subscribe to the explainer for more deep dives into the concepts shaping our world. Thanks so much for learning with us today, and I'll see you in the next one.